Welcome, I'm Aparna Tagare. In this presentation, we are going to solve one example in time series. Measurement of secular trend by method of moving averages and method of least squares. We are going to solve one example using these two methods. First is moving averages and second is least squares. See the example. Following table shows the all India infant mortality rates per thousand for years 1980 to 2010. Now here in this tabular form years are given 1980, 1985, 1990, 1995, 2000, 2005, 2010 and IMR, that is infant mortality rates per thousand. Here it is denoted by IMR. These infant mortality rates per thousand are given 10, 7, 5, 4, 3, 1 and 0. Obtain trend values for above data using 3 yearly moving averages. And second example is fit a trend line to the given data by the method of least squares. We are going to solve this example using first 3 yearly moving averages and then by second method of least squares. Okay. Now if we observe this given table year, that is these are values of variable t. Values of T are 1980, 1985, 90, 95, 2000 and so on. Now 1, 2, 3, 4, 5, 6, 7. These are 7 observations are here. Now if we observe difference between two successive years 1980 and 1985, it is of 5 years. 1985 then 1990, difference between these two is 5. Again 1990, 1995, difference between these two is 5. Similarly difference between these two successive years is 5. Similarly here the difference is 5, here the difference is 5. So difference between the two successive years is 5. Total number of observations are 7, that is odd number of observations are here. Now first we construct the following table to obtain 3 yearly moving averages. Now we want to find 3 yearly moving averages. Now 1, 2, 3, we consider first these 3 years and these IMR values 7, 10, 7, 5. We take average of these three values. Then we skip this first observation, then take next set of three observations. 7, 5, 4. We take average of these 3 years. Then we skip this and we take these three values, take their average, then we skip this, take average of next three, then we take average of next three values. And these are 3 yearly moving averages. Okay, here we are taking 3 yearly moving averages, so we have to divide the addition of 3 years observations by 3. Let year be t and IMR, this variable IMR we denote by xt per thousand. Trend values using 3 yearly moving averages. First we prepare this table, first column for year which is given, second column for variable xt which is IMR, these values are also given. Next column for 3 yearly moving total, we make column for total, and to get averages only we have to divide this total of 3 years by 3 and we get the required trend values. Now here years and this variable xt, that is IMR per thousand. Now 3 yearly moving total, we consider set of first three observations 10, 7, 5. We add them 10 plus 7 plus 5, we get addition 22 and we write this addition or total in front of middle of these three. Now middle of these 3 years is 1985, so we write this total in front of the middle year. Okay, this middle value 22. Then we skip this 10 and we take next three observations, that is 7, 5, 4. 7 plus 5 plus 4, we get 16 and we write this value 16 in front of this middle value 16 here. Okay, then we skip 7 and we take next three values 5, 4 3. Only we have to add them. 5 plus 4 plus 3, we get 12, and we write this value 12 in front of the middle. Then we skip 5 and take next 3. 4 plus 3 plus 1, we get 8, and we write in front of 3 middle value. Then we skip 4 and we take next 3. 3 plus 1 plus 0, we get 4. We write this 4 in middle. Now if we skip 3, there are no remaining 3 values, only 2 are remaining. So we stop here, making the total. So 3 yearly moving total. Here first observation is not present, last observation is not present, last total is not present. Now 3 yearly moving average, 22 is total. To find average, only we have to divide this 22 by 3. Since it is 3 yearly moving total, we have to divide this total addition of 3 years by 3 to get the average. So 22 divided by 3, we get 7.3333, which is 3 yearly moving average for corresponding to year 1985. Similarly, we divide the remaining values by 3. 16 divided by 3, we get 5.3333. 12 divided by 3, we get 4. 8 divided by 3, we get 2.6666. 4 divided by 3, we get 1.3333. So these are the trend values corresponding to the years. Here this 7.3333 is trend value for 1985. 5.3333 is trend value for 1990, and so on. Okay, so we get trend values using 3 yearly moving averages. Now here this first observation is not there, so using this moving averages method, it is not possible to find trend value for this first year 1980. Here it is not possible to find the trend value for 1980. Again, here in the last cell of this table, using 3 yearly moving averages, here it is not possible to find trend value for this year 2010. Here it is not there trend value for year 2010. So it is drawback of this method of moving averages, that is we are unable to find trend values of first year and the last year, in this case 3 yearly moving averages. If we consider 5 yearly moving averages, it will not be possible to find trend value for first 2 years and last 2 years. So it is drawback of this moving averages method. We cannot find the trend values for first few years and last few years in that time series. Again, second drawback of this moving averages method is we cannot get any mathematical equation between the two variables, this year t and this value x, that is IMR given variable. It is not possible to get any mathematical equation between the two given variables, that is years and the IMR values. Okay, so even if a few observations are added to the given series, that is if we know observations before 1980 and we write here, and after 2010 and we write here, then these averages will not get changed. Okay, so it is advantage of this moving averages that if we add even if a few observations are added to the given series, the moving averages calculated earlier are not affected and remain unchanged. So this is one advantage of this moving averages is if we add observations before 1980 and after 2010, then these averages already calculated will not get affected, they remain unchanged. So it is one advantage, but the two disadvantages are the method of moving averages does not provide a mathematical equation for the time series and hence cannot be used for the purpose of forecasting. Okay, and next disadvantage is sum of the trend values at each end of the given series. At each end means in the first and in the last, sum of the trend values at each end of the given time series cannot be estimated by this method. Okay, so here we are unable to get first year trend value, that is 1980, and last, that is it is 2010. These two trend values we cannot find using this moving averages method. So to overcome these two disadvantages, we use method of least squares. Second example, using same data, fit a trend line to the given data by the method of least squares. So years are given, 7 observations are there, IMR, infant mortality rates per thousand are given, 10, 7, 5, 4, 3, 1, 0. So total number of observations are 7 and difference between two successive years, 1980 1985 difference is 5 years, 1985 1990 difference is 5 years. Okay, so here number of observations are odd. So if we observe these 7 observations, this year 1995 is middle value. Before 1995 there are 1 2 3 3 observations, and after 1995 1 2 3 3 observations. Out of these 7 observations, this year 1995 is middle t value. Okay, now we solve this example using method of least squares. Here n is 7, that is total number of observations are 7, n is odd. Okay, odd number of observations are here. Middle t value is 1995. H, that is difference between two successive years, is 5. So H is equal to 5. We use the transformation U is equal to, if number of observations is odd, we use this formula, U is equal to T minus middle T value upon H. Here middle T value is 1995 and H is equal to 5. Substituting here, we get U is equal to T minus 1995 upon 5. Now we transform from this table from T to new variable U, and using this value U, we form the next calculations. The equation of trend line is yt is equal to a dash plus b dash u. Okay, now here a dash and b dash, these two are unknown values, and we find them, we find values of a dash and b dash by solving two normal equations. Summation yt is equal to n a dash plus b dash into summation u. It is first equation. And summation u yt is equal to a dash into summation u plus b dash into summation u square. This summation is also uh, uh, denoted called as sigma. We can read this also read as sigma. Sigma yt is equal to n a dash plus b dash into sigma u. Sigma u yt is equal to a dash into sigma u plus b dash into sigma u square. We can use either summation or sigma for this notation. Okay, so now we solve these two equations and find values of a dash and b dash. Now to get the values denoted by yellow color, summation yt, summation u square, summation u, summation u yt. We use this given data. These are values of t. We convert t to u using this formula, and these IMR, these values are denoted by this variable y. Okay, so to get this value summation yt, we require column for yt. To get this value summation u, we require column for u. To get this value summation u yt, we require column for u yt. To get this summation u, we require column for u, and this to get this summation u square, we require column for u square. So first we prepare table. We obtain summation u square, summation yt, summation u yt from the following table. Here these values are given here, yt, these values are also given here. So these two columns are given. Now u, it is equal to t minus 1995 upon 5. Okay, so using this value of t, first we substitute 1980 here in place of t. 1980 minus 1995 upon 5. So we get minus 15 upon 5, it is equal to minus 3. Now 1985, we substitute 1985 in place of t. 1985 minus 1995 minus 10. Minus 10 upon 5, we get minus 2. Then we substitute 1990 here. 1990 minus 1995, we get minus 5. Upon 5, we get minus 1. Then 1995, we substitute here 1995. minus 1995, 0. 0 upon 5 we get 0. Similarly here we substitute 2000, we get 1. If we substitute here 2005, we get 2. We substitute 2010 here and we get 3. So these are values of u, new variable u. Minus 3, minus 2, 1, 0, 1, 2, 3. Now u square, here values of u, their squares, minus 3 square is 9, minus 2 square 4, minus 1 square 1, 0 square 0, 1 square 1, 2 square 4, 3 square 9. The last column is uyt, that is product of these two, u and yt. 10 into minus 3, minus 30, 7 into minus 2, minus 14, 5 into minus 1, minus 5, 0 into 4, 0, 3 into 1, 3, 1 into 2, 2, 0 into 3, 0. So now to get summation yt, we add all these values. So summation yt is 30. To get summation u, we add all these values. We get summation u is equal to 0. Since number of observations are odd, we get single middle value 1995. It is middle value. It is single middle value since number of observations are odd. So we get here 0, and above 0 minus 1, minus 2, minus 3, and below 0 1, 2, 3. And adding all these we get summation u equal to 0, and this summation u equal to 0 reduces our calculations and we get answer quickly. Okay, now u square, to get summation u square we add all these values and summation u square is 28. To get summation uyt we add all these values and we get summation uyt is minus 44. Okay, so we get these four values required to solve two normal equations. Summation yt equal to 30, summation u equal to 0, summation u square equal to 28, summation uyt equal to minus 44. Now we substitute these values obtained from the table in normal equations. So remember these values, we are going to use them in next slide. Summation yt is equal to na dash plus b dash summation u. It is first normal equation. We substitute the values denoted by yellow. Summation yt is 30, a is 7 into a dash plus b dash into summation u equal to 0. So this term get cancelled. We get a dash is equal to 30 upon 7. A dash is equal to summation yt upon n. We get direct value of a dash. So 30 is equal to 7 into a dash plus 0. So a dash is equal to 30 upon 7 is equal to 4.2857. We get this value of a dash. Now second normal equation, to get value of b dash, summation uyt is equal to a dash into summation u plus b dash into summation u square. Second normal equation, we substitute these values here. Summation uyt is minus 44 is equal to a dash into summation u here 0 plus b dash into summation u square 28. So this term get cancelled and we get value of b dash equal to minus 44 upon 28. So minus 44 is equal to b dash into 28. B dash is equal to minus 44 upon 28 is equal to minus 1.5714. So remember here this b dash is negative. Okay, and when this b dash is negative, the trend is negative or trend is downwards. The equation of trend line yt is equal to a dash plus b dash u becomes. Now in this equation, if b dash is negative, trend is downwards or decreasing. If b dash is positive, the trend is upwards. Trend is positive. So the in this case b dash is negative, so the trend is negative or downwards. So we substitute values of a dash and b dash. Yt is equal to 4.2857 plus minus value of b dash is minus 1.5714 into u. That is yt is equal to 4.2857 minus 1.5714 u, where u is equal to this t minus 1995 upon 5. So we get equation, mathematical equation between the two variables y and u, and here u is t minus 1995 upon 5. That is, we get relation between the two given values. T is given and yt, that is IMR values are given. So using least square method, we can find mathematical relation between this time and given variable y and t. So here we get the trend line equation yt is equal to 4.2857 minus 1.5714 into u. Trend values computed using this equation are given below. To compute the trend value, only we have to substitute value of t, calculate u, and substitute that u in this equation of trend line here, and we get the trend value of the corresponding year. So year t 1980. So here we substitute 1980. 1980 minus 1995, we get minus 15 upon 5 minus 3. So u is equal to minus 3, and we substitute here u is equal to minus 3, and we get value of yt is equal to 8.9999. To get trend value of the year 1985, only we have to substitute this 1985 in place of t here. 1985 minus 1995 is equal to minus 10. Minus 10 upon 5 minus 2. So u is equal to minus 2. So we substitute this value of u minus 2 here. U equal to minus 2, and we calculate yt, which is the required trend value for the year 1985. Similarly, we can find trend values for all the years. Okay, so here we get trend value for the first year 1980 8.9999, and trend value for the last year in the time series 2010, that is minus 0.4286. So two drawbacks which were in moving averages method, that is of mathematical equation and about trend value of the first and the last year in the time series. These are overcome here. So we find mathematical equation using least square method, and we can find trend values of first year and last year also. Okay, so method of least squares is the most objective and perhaps the best method of determining trend in a given time series. Thank you for watching.